Alrighty, we'll go ahead and get started. Everybody, welcome to this week's Ken Reeves Memorial Weather Briefing. We're pleased to welcome retired AccuWeather meteorologist Elliot Abrams this day, March 21st. And without further ado, go ahead and take it away.
Hey, thank you, Kevin. And just raise your hand if you can hear me all right. Okay. Last Friday, I got to be at a meeting of the American Meteorological Society Board of Certified Consulting Meteorologists. I'm serving my second term on that board. We administer the written and oral exams for people who want to be CCMs. And I would advise any of you to apply for that. You need to be in the field of meteorology for at least 5 years. And many of you who are weather nuts probably have been that way for at least 10 or 15 years since you were maybe 5 or 6 years old. That was my case, but that doesn't count. You have to graduate first. But then in any case, then you can apply for it. And there are all kinds of consulting jobs out in the field, whether it's briefing individual clients or appearing in a court of law, or well, the sky's the limit, really. First, though, I wanted to talk about, before going into the upcoming weather, is the sudden snow squall that hit the State College area on November 19th. Now, if you may remember that, it was a cold day, a blustery day, and we had a blinding snow squall at midday. And I'll go through some of the things that accompany that event. First of all, on the satellite picture, it actually shows up pretty well as this green band that extends from central New York down through west central Pennsylvania. And this is a radar satellite composite. You can see all the various clouds here, infrared. And there's also some precipitation off to the east over here in eastern Pennsylvania and eastern New York. And it's rather unusual structure. It sort of looks like a summertime cold front. And that's actually the way it behaved. Looking at it in more detail at the surface, this is a surface map from early that morning. And the scale here is that the analysis here is every 0.4 of a millibar. So there are many more isobars than you'd normally have if you analyze the map by hand, for example, or even by computer. But here's Pennsylvania, and there's a little low pressure area in west central Pennsylvania moving eastward. And you can see how tight the gradient is with this particular system. And one of the interesting things I sometimes ask people, why do these lines look so funny out here over the Atlantic? And does anyone have an answer for that? I don't see any hands raised, but the answer is that there is actually no data here. And so the computer is just sort of, I mean, this is true artificial intelligence, that it's truly artificial because there's no data here to even analyze. Whereas here, there are all these pressure readings that are taken at different places on land. And so those are here, and then the analysis tries to meet that. Looking at the same picture on the standard infrared, and you can see the same band, western Pennsylvania here. See other clouds extending from, and snow cover also from Kansas across Illinois, and some clouds and precipitation out over the Atlantic. But there had been a cold front that passed a couple of days before to introduce the cold air. And this was essentially a secondary cold front that came in from south central Canada. Here, the ice over Lake Superior and Lake Winnipeg. And then this is the enhanced infrared. And in this picture, the front that's coming through west central Pennsylvania with the snow squall doesn't really show up that well, because here the coldest colors are generally the ones highest in the atmosphere, and these may be tens of thousands of feet above us. And so those high cirrus clouds that you often see with precipitation shields or the tops of thunderstorms will show up in these brightest colors, whereas a feature that's in the lower part of the atmosphere, or probably below 10 or 15,000 feet, will show up more faintly in a picture like this. And that's the case with this picture. And the water vapor picture shows this, and it doesn't look particularly moist with the system over west central PA, although it does look dry behind it. And you see more moisture over along the eastern seaboard. And here you find whatever noise that is. Looking at the temperature map pattern, just to orient yourself, we'll find Pennsylvania over here. Here's northern Pennsylvania border, southern Pennsylvania, and temperatures generally in the upper 20s to the low 30s. And the flow is out of the west northwest at the surface. And it's cold all the way into the deep south with this. Temperatures dropped to near freezing and even below freezing in parts of the Carolinas and Tennessee. And then with the upper air pattern, this was the situation at the, which level am I looking at here? It's good to label all pictures. This is at 850 millibars. So you're about 5,000 feet overhead, and there's a northwesterly flow. You can see a trough here. That's the cold front at this level. And 50, 60 knot winds are in this at 850. And so when it's a relatively warm at ground level and cold up here, there'll be the downward transfer of horizontal momentum, and we'll get strong gusty winds at the surface with a pattern like this. And that's what we look for to see if there's actually going to be some very high wind once you figure out if it's going to be unstable enough. Whereas out here in Arizona and New Mexico, there isn't that much wind. There's hardly any gradient here. And then looking at the 500 millibar pattern, this is with vorticity on it. Doesn't show too much here at western and central Pennsylvania, but you do see the trough that's dropping in across the Great Lakes, a strong feature. And offshore, there is a jet stream, and the original cold front has gone well off the coast. Looking at the composite precipitation on this, doesn't really look all that terrible. Western and central Pennsylvania is a band of snow and rain, and you can see mostly rain over here in the east. Let's look at a couple of observation points. And if you have your magnifying glass, you might be able to see this. But this is Bradford, PA, KBFD. And just to read it, this is 19, which is 19th of February, 1348Z. Now, that's 9:48 in the morning, or 8:48 in the morning standard time. It'd be 9:48 in the morning daylight time. So here we see the squall just coming through there. First, the wind is out of the west-northwest, 28 knots, peak wind, pressure rising rapidly. And you can see snow squalls, quarter mile in snow at the Bradford airport. And one question is, how many people live in Bradford? And some people say it's as few as possible, which is the same answer as for International Falls, Minnesota. Whereas how many live in Florida? Many people live in Florida, but they don't get much snow. So anyway, looking at the conditions, it gets colder and colder. Here's the very heavy snow, S+ type snow. And you ask, well, how much precipitation was there? Well, since this is an automated reporting station, it doesn't really measure snowfall. So the P shows zeros there. And so if you were to brief an attorney on how much snow there might be, it might have fallen, you'd have to look elsewhere for that kind of information because it's not on this report. The precipitation is zero. I mean, nothing's been melted there. And so whatever precipitation fell is not measured. The contrast at University Park, well, not contrast, the same situation. Here we have at a couple of flurries just at 9:45 in the morning. And then at 15:53 Z, this is a 10, just after 10 in the morning. And then as we go toward 11, suddenly we have a dropping of the visibility to a quarter statute miles in snow. So that's just a couple of hundred yards. That's really the only observation that gives you any indication that something happened around here. Just for, and you don't really, it began at around 11 o'clock and it was over in 15 minutes. So here's the pressure situation that existed at the time. Here's a cold front moving across west central PA, strong gradient behind it. And you can actually see some of the effects of the slight warming that occurs downwind of the Great Lakes. There's a little cyclonic curvature here east of the Lake Huron area. And we also see a bit of cold air damming with the cold air stacked up against the Appalachians. And then the front, and part of that's the fact that the front hasn't come through. So you wouldn't expect it to get colder right away. But here is the trough line coming through central Pennsylvania. And here's the no data region. That earlier map I showed you and told you that it was from that day, that was actually the night before. But here's some more data points. Here's Newark, New Jersey. And at the same time that central Pennsylvania was getting the snow squall, they start to get some rain that turns to light snow farther to the east. Here, though, the wind is 170 at 13 knots. So it's out of the south. The cold front has not yet arrived. Then here at 1751Z, there's more of a westerly flow. And here, rain began at 17 minutes after noon. And then you can see some showers of snow later, but the visibility doesn't drop all that much. So as is typically the case, if you grew up in New York or Philadelphia or Reading, places like that, you'd hear about all the snow downwind of the Great Lakes in Buffalo and Cleveland and be hoping it would come to your location. But unless somebody knocked down the Appalachians, that wasn't going to happen. The thing that used to strike me often growing up in Philadelphia was watching a nor'easter, and it would rain outside. And I knew that it was, say, snowing in New England. I would say, okay, with this northeast wind, shouldn't this change to snow? But then later in school, you learn that we have veering of the winds with height, warm advection, and that there's a big difference between what's happening down here at the ground and what's happening aloft. And so even though it might look like, or you might think that rain is going to turn to snow because of a northeast wind, if you look several thousand feet overhead, there's actually warming taking place and you're not going to get the snow. Now, the National Weather Service did a particularly good job with this squall prediction. This was a forecast made at 9:09 a.m. Central or 10:09 a.m. Eastern Time. And it says here, a fast-moving squall will continue to accompany Arctic cold front across central portions of New York and Pennsylvania. And I like the way they describe this. They say that there will be places reporting heavy snow and brief blizzard conditions with visibility at or below a quarter mile. Now, when you hear the official definition of a blizzard, some say that you have to have blizzard conditions for 3 hours for it to be called a blizzard. I've always wondered about that because the term blizzard actually came out of the Midwest. It was actually used to refer to a baseball team in northern Iowa called the Northern Blizzards that hit a lot of home runs. And the term then became used for the whiteout snows that they had in that part of the country. And so blizzard is not a scientific term. It's not like the equation of the gravitational relation or the hydrostatic equation. It's a made-up term, and it's over the years it's been honed down. And I think the official definition is that these conditions have to last for 3 hours. But as far as I'm concerned, if you walk out in the middle of a snow squall with a visibility of 0, that's good enough to be a temporary blizzard, and that's what the National Weather Service was correctly predicting. Now, at the same time, the PennDOT signs on the interstate told a different picture, and they said, be ready for changing weather conditions. And a few of them said, watch for winter weather conditions. And if you think about that, every time from December through March, there'll be winter weather conditions and changing conditions. So unless the language is extremely specific, people really don't know what to do. If you're going to drive into this thing coming from the east, it's going to be like driving into a wall. And I think of an analogy with the summer hurricane that came up and killed people in the New York City subway. National Weather Service had predicted several hours before that there would be intense rain over a small area. And they have inundation maps made to show where the flooding will occur. And I'm sure there was one that could have told that the subway was going to flood if they had that much rain in a short period of time. But the key to saving people's lives is getting that information to the right people. So the National Weather Service made this forecast, but in the middle of the night, did the right people actually get the warning and say, okay, we have to shut the subway down because otherwise it'll flood and people could drown. Until we make that communications connection with all these events, we're going to see more loss of life than we have to. So I took a time lapse of this picture of this storm, expecting it to occur. And this is looking out my backyard toward the north. And there are a few weather stations out here, one or two of which may actually be working. But here is at first you see this is flow from basically west-southwest to east-northeast, and doesn't look particularly menacing here. In the time lapse here, I'm taking a photograph every 4 seconds, and that's why it's all sped up here. But as we get closer to the event, watch the visibility drop and then go to dead zero. You can see nothing. There's a tree out just 50 feet behind the house. Some of these markings here are just snow that hit the window. And that was as the storm approached. And then as the storm left, the next slide here. Still terrible visibility, and then slowly it improves, and you see that the accumulation that occurred wasn't that great. Remember, in the early part of the first slide, the grass was almost green, whereas here there's maybe a ½ inch of snow. And yet, if you had driven into that squall from the east, you'd have driven into a wall, and that's how chain reaction accidents occur. Now, if you're driven from west to east in that same situation, it might not be quite as dangerous, because you'd encounter first some snow on the road, and you'd see this thing ahead of you, and you realize, well, okay, the road was dry and now it's snow covered. Maybe I need to slow down a little bit, but still you're going to drive into a wall from the west. But I think the worst situation is when you come from the east with an eastward moving squall, and you drive into it and suddenly you can't see a thing. And of course, you don't know what's in there, whether it's a good roadway or you're going to get killed, which we hope does not occur. Okay, so that's this time lapse. Now here is our dog looking at the scene last week after the last snow had melted. He was very sad. This dog likes snow. He actually wished last fall that he could go to a whiteout football game. Here he is. His name is Scotty T Dog. The T stands for the. But in any case, that's our dog, and he likes to go out in the snow, and he also likes to go out on the ice while I'm walking him, and that is a great hazard when you're 74 years old. Looking at one of the soundings with this event, this is in the upper Midwest during that Saturday morning, and you can see cold air in the lowest part of the atmosphere, which is you'd expect. But look at the way the temperature curve here. It's almost as if the stratosphere or the stratopause has come all the way down to the 700 or 800 millibar level. There was a stratospheric intrusion with this event. The actual stratosphere began up here at this 300 to 400 millibars, but it's usually higher than that even. And so this was a rather unusual weather situation. And then as the storm continued, you can see it moved off the coast. Now this is today's picture that I got about an hour ago. And there's a low pressure area east of New England, high pressure area in the southeastern states, right here in North Carolina into South Carolina. And there's a southerly flow through the Midwest, and there's probably a warm front here on the line from Iowa over into just near Chicago. And this kind of an analysis is very good for picking out exactly where the fronts are in close call situations. And backdoor front situations where, like, it's warming up in Johnstown and Pittsburgh and Morgantown, West Virginia, and here we're stuck at a 45 or 50 degree, dull, dreary, drab air mass where we look at the clouds and it's like an endless carpet of steel wool pads scraping across the sullen sky. And not only that, it's dreary, dull, damp, and dim. But so finding the fronts is crucial, and this is one way of doing it. And the telltale thing with this front, if you looked at the flow aloft, it's going to be pretty much parallel to the isobars at ground level because the warm sector is typically uniform. But higher up, you'll have veering winds with height. And so you'll have the southeasterly flow here across, like we have in Wisconsin and over into Michigan, and the flow aloft might still be southwesterly here. I'm going to switch now to forecast for this coming week the next week. And what I tried to do here, to look at the 15-day forecast, I don't really believe that you can forecast out that far very accurately. And so I sort of used a color scheme that I didn't do that well to hide the forecast, so you really can't tell what it says here for the second part of this period. But here's today, temperatures heading into the 60s, beautiful day, spring, blue sky, cumulus clouds, and then tonight going back down to the upper 30s. And then tomorrow looks pretty nice too. It's like on Wednesday, frontal system comes through with some rain, maybe a thunderstorm or two, but it's not terribly cold behind that until you get toward the end of the week. Temperatures here, this is Saturday and Sunday, cold front comes through, and it's possible that there's some rain mixed with some sleet or snow. We'll have to see how this goes, but that's the last time it can really possibly do that in the month of March. And the reason for that is that March is coming to an end pretty soon. And of course, we've had snow in April, sometimes even in May, but there's at the moment no sign of it. So that's that picture. I'm going to switch to my internet screen here so I can actually see and show you a couple of the progs. I think this is still not okay. That's not it either. If I knew what I was doing here, I'd actually be dangerous. Okay. Okay, so here's some of the current situations, and we'll look at an ensemble mean forecast for this week ahead.
So real quick, you might have to reshare your screen. I think you just shared PowerPoint.
Oh, okay. All right. I will reshare my screen in a second. Thank you for telling me that. It says on screen sharing, but that doesn't actually mean anything here. Oh, okay. So the one I want to share, okay, first I actually want to share a time lapse I took this morning. Is that showing up?
Yes.
Okay. Well, this is a severe thunderstorm situation first, and you can see all the clouds ahead of it. This is a south to southwesterly flow at ground level. You can see that the flow is somewhat veering with height. This is the same view as before during the snow, but in this case, a strong thunderstorm is going to come through. And as it came through, it uprooted some trees in parts of central Pennsylvania and knocked out power for a while. And then things gradually returned to normal, but you'll see it become darker and darker in the west and northwestern sky out here as the system actually approaches. We're not there yet. We've still got a minute to go here before the actual storm arrives, which you'll see. But it becomes more and more ominous as it gets darker and darker, and more and more sunlight blocked and muted by the thick clouds. And now it's getting darker on the left side of this, and all of a sudden we'll see the actual thunderstorm approach.
So real quick, I'm sorry. It looks like we're still having trouble seeing.
Oh,
Sorry about that.
no, let me go back to the Zoom here then.
So I think if I stop this again and then you went to share, there should be, when you press share screen, there should be an option to share like your entire desktop, I think. And that should work. There we go.
So you can see that thunderstorm now?
Yes.
Well, let me back it up there to where it wasn't here yet. It's convenient to sometimes after a disaster, you wish you could back it up so that the disaster didn't occur. But life doesn't work that way. In any case, you can see it becoming darker toward the horizon. This is last summer. And then finally, as the storm actually approaches, it gets really dark. I'll speed up a little bit here. And now it's actually almost calm. There's hardly any wind at this point. And then the actual storm appears, boiling clouds, and the rain is actually in this clear. A lot of people think when we get into that lighter color sky behind this, that means the storm is passing over. But what actually means is you can't see the individual clouds because it's raining so hard. The rain hides the clouds, and that's what's happening in this side. There's actually a big drop sitting in the middle of my screen. Right, this is my storm window that's outside the house. And so when the flow goes northwesterly and it's raining, you don't see too much. And then as the storm moves away, it gradually becomes brighter. And at the end, just 10, 15, 20 minutes later, you can start to see some blue sky. Okay, I'll get rid of this, go back to the forecast section, and hopefully. Now, is this part of the screen visible?
Yes.
Where it says AccuWeather.com professional? Okay, this will be the, I'm not going to look at the ensemble mean right now. I'll go out as far as I can with this thing. I like working with ensembles, but one of the problems with the ensemble is the ensemble mean isn't necessarily going to hit what's actually going to occur. The model is being run over and over and over again because we don't have exactly the same information going into the model. And so the results are going to be different. And so sometimes you look to see if you've got a lot of members in the same direction or just a few members, but you always have to look for the possible outlier and then compare the forecast one to another, one day to the next, or run to run, to see how the forecast is going to work out. Now here's the initial at 8 o'clock this morning, Eastern time. Low pressure area, we already saw that in the more detailed surface map of low pressure area in South Dakota. And as we go ahead to tomorrow, same time, 8 a.m., you see snow occurring across the plain states, this blue area. Here in the east, this suggests there might be a little freezing drizzle first thing tomorrow across northern Pennsylvania and southern New York. Not really sure that'll happen. Depends how quickly it can cloud up tonight. But there isn't a lot of precipitation over on this side. And then as we go through tomorrow afternoon, here's Tuesday evening, tomorrow evening, could be some severe weather across the area from Louisiana into western Kentucky. If we went to the Storm Prediction Center site, we might see a prediction outlook for tomorrow. But in any case, this looks like very heavy rain, but you've got warm, moist air coming up from the Gulf of Mexico, strong cold front approaching from the west with probably a dry intrusion behind it. And so this is a dangerous situation for those living right in that area, for the flash flooding, where you get the rain falling in gutter gushing rivulets and filling the street, turning the streets into streams and the alleyways into, well, it floods. And then looking ahead to Wednesday morning, the thing is weakening, but still moving eastward. The low pressure areas out here in Illinois, and some heavy rain still in the Tennessee Valley. And here in the east, big question for Wednesday would be whether we get into the warm sector during the day or we get an easterly flow and low clouds develop. You can't really tell from this map which is going to occur. I mean, it'll be fairly mild, it's not going to snow, but in this area, western Pennsylvania, where I have the cursor, probably goes up to 70 to 75 degrees ahead of this front. But in eastern Pennsylvania, we might have more of a southerly flow. Remember, with our mountains oriented from southwest to northeast, wind straight out of the south actually has to upslope coming up into the mountains here. And that's why when you see these warm air masses come from the west, they usually don't make it in right away because the cold air is more dense and it just sits here at ground level. And then we go into Wednesday afternoon, Wednesday night, frontal system arrives, some showers, thunderstorms, and it looks pretty chilly behind it, although not immediately for us, because if this is right, here on Thursday, some drying occurs coming up from the Ohio Valley into Pennsylvania. It starts to dry out. And then Thursday, 2 p.m., if this is right, the front is stalling and there's a new wave forming on it, making it rain in parts of the southern mid-Atlantic region. But back here in the mountains, we may have clouds and sunny breaks, and it could be in the 50s and 60s at this point. Snow showers here in the Midwest. So we wouldn't expect any snow showers locally with the first front. And the big question in my mind would be whether this wave forms this far east and misses us, or instead maybe the front stalls farther west and we get rain. So the forecast at this point would be it either will or will not rain, depending, and we can be sure of it. And looking ahead to Friday, here's that system still off the coast. I mean, it's really going to pour there. It doesn't matter if you're a fish in the ocean, but it doesn't matter if you live next to a stream in southern New Jersey with this. And then as we go into the weekend, here's Friday afternoon. It's like looks kind of miserable really for the last weekend in March, or the way it starts. Looks like there'll be a lot of clouds around. Not sure there will actually be snow flurries, which is the computer is telling us that it'll be cold enough for snow, but this time of year it's maybe too warm, the lowest couple of thousand feet. But it does look like it'll be overcast everywhere from the Great Lakes eastward. And this chilly air is is well established. If you look at the 1,500 thicknesses, that won't really tell you the temperature, but the would-be snow rain line is way down here in Georgia. And so the flow is coming out of Hudson Bay. Interesting geographical thing is that I guess Hudson didn't really want to own that bay because otherwise it would be called Hudson's Bay. But in fact, it's Hudson Bay, and maybe he didn't want to own it. But so there's Sunday. And then finally, I guess next week, we get into a warming trend, but it takes a few days. So it's going to be kind of miserable or overcast as we go into the last weekend in March. But then we go into April. And of course, in April, the weather's always beautiful, except during the thunderstorms. And it's severe weather season. And everyone will be interested in watching how that progresses. As we go into the summer, I wouldn't be surprised if we see some temperatures in the 80s, maybe the 90s. Nights in the 70s, but then for all the leaves that come out during April and all the plants and the flowers, I would predict that sometime in late September, October, you'll start to see those leaves fall off the trees. There'll be lots of raking, and there'll be football games. Then it'll get chilly, and then before we know it, it'll be Thanksgiving time. Some people will probably eat turkey at that point, and then it'll get colder, and we'll go through the whole thing again, get to the barren days of winter. And that's the forecast for a year ahead.
I don't know if you saw the Q&A thing that popped up for you. Of course, panelists are the only ones that can see it now because we got rid of chat, but you have a note from David Novak, and I don't know if you're able to see it or not, but I think it was a pretty nice note that he left you.
Well, David was one of my favorite workers when he worked at AccuWeather, and just a tremendous person. Very, very smart person too, as everyone watching this is. Does anyone have any other questions though?
Yeah, feel free to pop it in the Q&A if you have a question. We'll give that a minute.
Okay.